So, good morning, all, and let's start with semiconductor devices. Hopefully, you have revised 11 standard semiconductors. I had instructed so. So, it's up to you whether to revise it or not. Now, this year we'll be starting with semiconductor devices. Okay. So, devices which we use commonly in electronic circuits. Okay. Or as components, right? There are some components also which we'll be studying, like photocell, LED, IC chips, that is ICs. So all those things we will be studying. But basically, the semiconductor device is first of all used as a rectifier. So a simple diode is used as a rectifier. So that particular thing we will be starting with. Okay. So PN junction, last time we have studied. Let us start with the use of that PN junction diode, and that is to rectify the things, right? So see, I'm sharing the screen. We shall start. Okay. Just a sec. Huh? Till that, open your books. Have a pencil in your hand. So see the things. This is the introduction of semiconductors, or semiconductor use of semiconductor as a rectifier, right? So see that a rectifier is an electrical device, right, that converts the alternating current which periodically reverses direction. Alternating current means the current or the voltage which reverses its direction periodically. Okay, this is AC. This is the output of AC generator. So the voltage or current which is periodic, right? So in one periodic time, one cycle is completed. Means one once in the half cycle it will be positive, and the other cycle it will turn or it will reverse its direction and it will be negative. So it is sinusoidal in function. Okay. Now, which periodically reverses direction into the direct current. So basically, rectifier is an electrical device which converts the alternating current into direct current. Direct current means the ones which you have used till now. That is with the electrical cell. The current which we get is a direct current. That is, it doesn't reverse its direction, which flows only in one direction. So this process is known as rectification. Physically, rectifiers take a number of forms, including vacuum tube diodes, mercury arc valves, copper and selenium oxide rectifiers, semiconductor diodes, silicon controlled rectifiers, and other silicon based semiconductor switches. Okay, so all these are nothing but the rectifiers. So I hope you have understood what is meant by a rectifier, right? There are two types of rectifiers. which are, one is half wave rectifier and the other is full wave rectifier. Now by the name also it is very clear. Since it is a wave, remember, the thing is, now the alternating current is in the form of a wave. It is a periodic in time. So it is in the form of a sinusoidal wave, right? A wave is there, and it certainly it has a fixed time to complete that particular wave. So it is periodic. In one period, one wave is completed. So if a half wave of that is rectified, then it is known as half wave rectifier. And when a complete wave, that is full wave, is rectified, it is known as a full wave rectifier. Now, half wave rectifier. The process of removing one half of the input signal to establish a DC level is called half wave rectification, right? As I said, in half wave rectification, the rectifier conducts current during positive half cycle of input AC signal only. That is only in positive half cycle, that is first half cycle of the current, the diode works, or the rectifier, the output is rectified. Now the negative half cycle is suppressed. So negative half cycle is not rectified. Okay, output will be 0 in that case for this half wave. See the diagram, see the construction of half wave rectifier. Here is the AC supply, right, which is the alternating current supply. From this alternating supply is not given directly to the diode, it is given to the step down transformer. Since its voltage is very high, so it needs to be reduced. So after this step down transformer, this is known as V in. So this is actually our V input. This will be given to a diode. You know that this is its positive junction, this is its negative junction. So this is PN diode. Okay. So PN junction diode. Then after the diode, a load resistance, that is across which you will be taking the output, that is attached, and the circuit is completed. Okay, a simple transformer is used. Now see that our input is V in, which is sinusoidal in function. So it is positive in the first half cycle, the input is positive. The second half cycle it is negative. So here one wave is completed, so one periodic time is complete. Now see that when this wave is given over here, that is in this first half cycle, let's see what happens. Here the diode is positive, so its P terminal is positive, means it is in forward bias. Okay, it is in forward bias mode. So the diode conducts. Diode conducts means after 0.7 volt for silicon or 0.3 volt for germanium, which is the cutoff voltage or knee voltage we call it as, the diode will be a conductor. It will be a smooth conductor. So this will, it will give you the output across this load resistance. The output will be only for this first half cycle. Okay, so this can be taken as V out, and the current is flowing through the diode for this particular half wave or half cycle. So this current also can be shown like this. Understood? Now let's see what happens at this other half cycle, that is in the negative half cycle. So in negative half cycle, see that this particular positive terminal of the diode, it becomes negative, and negative terminal becomes positive. So it becomes reverse bias diode. And in reverse bias mode, diode doesn't conduct. If it has to conduct, it needs lot much voltage for that, and we don't provide that much voltage. So we say that it is in the inactive mode or non-conductive mode, and therefore here you can see that in this other half cycle, that is in the negative half cycle, or for negative input voltage, current is 0. Similarly, the voltage will be 0. So this gap will be present over here. So see that here only half wave is rectified. For only half wave you will get the output, and therefore the name is half wave rectifier. I hope is understood. Is it? Let me know. सांगा बेटा समजलंय? Yes or no? मुलांनो आहात? जागे आहात ना? सांगा. Yes, anybody? सांगा बेटा. ओके ठीक है, चला पुढे जाऊ. So this is the working of half wave rectifier, which you can see over here. That's what we told, or rather I told you just now. So see that this is the output frequency and input frequency chart. So if this is the input frequency, see that this is the will be the output frequency, and so see that f out is equal to f in. Output frequency of the wave is same as input frequency, remember. Okay, do make a note of this, because in MCQs always such type of questions are asked. Now let's see advantages and disadvantages of half wave rectifier. The advantage is the circuit of half wave rectifier is very simple and of low cost, naturally, because it consists of just a single diode and a single resistance. Disadvantage is the pulsating current in output contains AC components whose frequency is equal to supply frequency. So filtering is needed. Now see that though we say that output is a pure DC signal, it is not so. Since it is also a pulsating nature, it is pulsating in nature, it also contains ripple voltage or AC signal. AC signal is superimposed on DC signal. Okay, so that is there in this output wave also, which is unwanted. So to have that unwanted thing figure out, we need a filter. Okay, so this AC supply delivers power during half cycle only. So output is low, as we just saw. So to avoid these disadvantages, what we do is instead of one diode, we use two diodes, okay, known as full wave rectifier. So in full wave rectification, current flow through the load in same direction for both half cycles of input AC. Okay, so as we talked about one half cycle, the in other half cycle also the other diode will be acting, and see that though it is so low in the load resistance, the current is unidirectional. Current flows through one direction only. Now this can be achieved with two diodes working alternately. Now for one half cycle, one diode supplies current to load, and for next half cycle, another diode works. Okay, see how it works. It's a nice thing to see and to get the understanding of this particular thing. To have this, we here use a center tap transformer. Okay, previously in half wave rectifier, we use just a simple transformer. Now here you use a center tap transformer. Now how does it look? Let's see first. See, this is the picture of this center tap transformer. Here in the primary, no change is there, but across the secondary, from where we take the output, it has three terminals. Okay, usually it has two. Now it has third terminal also, which is at the center of it, so known as center tap transformer. Okay, so here it gives you this particular half thing. That is upper half circuit is one circuit, and the other half circuit is the second circuit, as if. Okay, so you can take out output from rather in both these circuits you can get the output, or you can get the input, say. See the things. So in the first half cycle, see that this particular thing will be positive, this will be negative, this will be positive, this will be negative. Okay. Just a sec. Let's see this. See this here, I can write it as positive. Okay. In first half cycle, this is positive. This will be negative. Over here, it will be positive. Here it will be negative. Understood this much? Okay. Now see what happens. In the first half cycle, as this terminal is positive, so this particular first diode D1 will be in forward bias mode. So the current will flow from this diode. It will come over here and it will pass through this load resistance and it will end over here, right? So you get output voltage across this particular resistance. Now in this, at the same time, see that this terminal is positive, this is negative. Now see that as this B terminal becomes negative, D2 is in inactive mode. This is in the reverse bias mode. Okay, so we won't get output from this. So in the first cycle, D1 will give you output. Followed. Now see what happens in the next half cycle. In the next half cycle, let's see what happens. It is here it becomes negative. This becomes positive. Oh, sorry. I'll take the other one. So here we can see that, sorry, pen. Okay, here I can mark it as negative. Now here if I take it that this as negative, I'm unable to find the pen now. Let it be, huh? See this? Here in the next half cycle, suppose this A terminal is negative. Okay, this is positive. Okay, over here I can draw it as positive. At this center tap again, this is negative, and this B terminal becomes positive. Okay, followed. Now when this B terminal is positive, see that D2 is in forward bias mode. So now see that current flows from this center tap to this D2, then from this D2 over here, and this comes out, flows through this load resistance RL, and then comes back to the center tap. Means, again see that from this load resistance, current is unidirectional. The direction in which it flowed or it was flowing in the first half of the cycle, in the same direction it flows in the second half of the cycle. No doubt, only thing is in the first half cycle D1 was in forward bias mode, and here in second half cycle D2 is in forward bias mode. Okay, so see that in the complete full cycle or the full cycle of wave is rectified, though across both the different diodes it is rectified. That is very important. So it is called as full wave rectifier. Followed, thus see that output voltage will look like this. So you get voltage throughout the cycle, throughout the complete cycle. Okay, now just a second. So I hope you have understood till this much. Now take the homework as advantages and disadvantages of both the diodes, that is, or both the rectifiers, send half wave rectifier and full wave rectifier. Okay, I'll be sharing this PPT with you. Fine. And this particular unit you will complete now with all the theoretical questions, and if MCQs are there, you will solve them also. Okay. So I hope you have understood today's lecture. Have you all? Just let me know at least now. बोला मुलांनो मला कळू देत. हा समजलं इथपर्यंत? ठीक आहे. तुम्हाला पीपीटी शेअर करते, रेकॉर्डिंग पण पाठवून देईन आणि पीपीटी पण पाठवून देईन. ओके. And from the next lecture, we'll be starting with, I think photocell is the next concept, right? Because Zener diode is not there in this syllabus now, means for this evaluation of this year's evaluation. No doubt, if time permits, we'll be studying Zener diode also, okay? But after this, we'll be starting with photocell. So do have notes of next 3 units with you. So wish you all the best and do come for your practicals at your regular time, right? So bye for now.